Okay, today's lesson is about completing the square. Completing the square is a method of solving quadratic equations and factoring trinomials. So we're going to take a look at this. There's some pre-knowledge that we need to already know before we start on this, and that is, how do you take half of a number? Seems elementary, but let's go ahead and talk about it. If you're taking half of an even number, then you simply divide it by 2. If the number's odd, well, you just want to put it over 2 and reduce if you can. If it's a decimal number, then we'll just simply multiply it by 0.5. And if it's a fraction, then we'll times it by the fraction 1/2. Now, these are the most convenient ways of finding half of different kinds of numbers that we're going to run into in this section. To square a number, you simply multiply it by itself. Okay, let's take a look at what perfect square trinomials are. If you take a binomial, multiply it by itself, you get what we call a perfect square trinomial. And here's an example. We'll take x plus 3 and square it. And of course that means take x times 3 and times it by itself. And of course we use the FOIL method. We take first times first, or x times x, we get x squared. The outside would be x times positive 3. That'd be 3x. The inside would be 3 times x. That would be another 3x. Together they would add up to be 6x. And then you take last times last, positive 3 times positive 3, and get positive 9. A little simpler way of squaring a binomial is a little rule. You take the first term and you square it. You take the first term times the second term times 2, and that's where we get the 6x from. And you take the second term and square it, and that's where we get the 9 from. So first term squared, twice the product of the first times the second term squared. That's a little shortcut. Okay, what I want to talk to you about now is the relationship between a binomial that we're going to square and the resulting trinomial that you get after you square it, and how these numbers, this constant, how it relates to the linear term and then the constant on the trinomial. Okay, so as you can see right here that 3, you square 3 to get 9, or if you want to go from 9 back to this number, you'd have to take the square root of it. So these are squared square root. Okay, going this way it's squared, coming back it would be square root if we wanted to find out what went up, what here. As far as it relates to the middle term and this term here, why that's times 2 gives you this one, divided by 2 gets you back 3 times 2 is 6, 6 divided by 2 is 3. So we need to know how these numbers relate to each other. Okay, so I've got a little practice down here we're going to do, and I'm going to put in a number, and I want you to see if you can tell me what the other numbers would be. So if this number is 4, okay, well then this would have to be twice that, would be 8, and we'd square it to get this number. That would give us 16. Okay, so that's what those numbers would be. All right, let's take those out. And what if I gave, see what I want you to be able to do, if I give you any one of these numbers, I'm going to look for you to put the rest of those answers in. So what if this number is say 10 here? Okay, what's the relationship between this number and this number here? Well, we take half of it, so this number would have to be 5. And then how could I get this number? Take the 5 and square it, and it would give me 25. Okay, so x plus 5 squared is going to equal x squared plus 10x plus 25 if you work it all out. Okay, all right. Let's put let's look at what if this was minus right here. Okay, so let's put in 2 here. Let's put in 2. Okay. So if it was x minus 2, then again this is simply going to be twice as much, or negative 2 times 2 is negative 4. And then here you're going to take negative 2 and square it to get this number. Well, negative squared is going to be positive, so that's going to be positive 4 there. Okay. All right, let's try something else here. Let's put a number in here at the end. And what if this number is, let's see, let's go over to this one. What if this number is 49 here? Okay. So to get this number, going back, we're going to do what? We're going to take the square root. So going back, we take the square root of 49, which is 7. And 7 times 2 would be 14. Okay? So given any one of these three numbers, we should be able to find the other two. All right? Let's move on. Okay. And let's see. Pause the video. Okay, had to adjust the parameters of this video. Okay, so now here we want to look at the relationship between the b term and the c term in a perfect square trinomial. And as you can see, the relationship between 6 and 9, to get from 6 to 9, well, if we go backward to this number, we would divide by 2 and then we would square it. We can just divide by 2 and square it and go straight to here instead of going back to this. So we need to see this as divide by 2 and square, and that's how you get this number right here. Now that's going to be what we're going to be doing, or half of it squared, as I wrote over here. That's what we're going to be doing in completing the square. Okay? All right, now suppose we want to make a perfect square trinomial, and we know that the first two terms are x squared plus 8x. What would the constant have to be for that to be a perfect square trinomial? Okay, so that's what we want to figure out. Okay, as shown in the example above, the way you get from the middle term, this would be the middle term 8, to the constant, you take half of it and square it. So if the first two terms of a perfect square trinomial are 8x squared plus 8x, x squared plus 8x, then the last term, or the constant, would have to be half of it, so I put it over 2, and which 8 over 2 is 4, and square it. This would have to be 16. So the perfect square trinomial, with the first two terms being x squared plus 8x, would have to be x squared plus 8x plus 16. This is what we call completing the square. Okay? And the binomial that you square to get it would be x plus 4 squared. All right, that's the completing the square process. All right, example number 1. What would c have to be for the expression to be a perfect square trinomial? Okay, so we know that we're going to divide that thing by 2. We're going to take half of it and square it. So it's 8 divided by 2 squared. 8 divided by 2 is 4. 4 squared is 16. C would have to be 16 for the entire thing to be a perfect square trinomial. All right. Then if we're asked to factor the perfect square trinomial, it would factor into x minus 4 squared. Okay. So we take this, and we'll notice that there's the sign between these. It's going to be x, and it's going to always have what this sign is. So it's going to be minus, and then of course it's half of 8 is 4, so it's x minus 4 squared. So let me note that these signs are always going to be the same. In the trinomial, the sign on the linear term, or the x to the first term, whatever that sign is, that's what's going to be between the two terms in the binomial that you square to get this perfect square trinomial. Okay, so try this, complete the square, and factor the following. Okay, so we want to know what would c equal, and then once we find that number for c, what binomial is it that you would square to get that perfect square trinomial? Every perfect square trinomial is the square of some binomial. We want to be able to look at these numbers and figure out what it would be. Okay, well, we take that term off of the the coefficient of the x term, and it's even, so we divide it by 2 to find half of it. We take half of it, which is 6, and we take that number and square it, which is 36. So c would have to be 36. So to make this a perfect square trinomial, this would have to be 36. So it's x squared plus 12x plus 36. The other part of this is being able to write the binomial that you would square to get this. Okay, so we know it's going to be x up front always. And then this is the sign that goes between the two terms, and it's just exactly half of this, or the number that we squared over here. And if you take x plus 6 and square it, you get x squared plus 12x plus 36. Okay. Example number 2, complete the square and factor. Okay, so we're going to work this one together. So to find out what c is, we take half of this number, and you know, that doesn't simplify. So we can't do anything with it except write it as a fraction, and then we square it, which is going to be 49/4. So to complete the square, it would be, c would have to be positive 49/4. Okay? And the binomial that you would square to get this would be x minus half of this, or whatever you squared over here. x, it takes this sign, minus, and whatever's being squared, or half of 7, is just 7 over 2. We would not reduce that any further than that. So now, they don't always turn out to be pretty, and here we ended up with a constant that was a fraction, and then our constant in our binomial that we square is a fraction as well. That can happen. Every time this number is odd, this number will be a fraction, and so will this. Okay, you try this one. Okay, we take this number 11. You notice I haven't been taking the sign, and it really doesn't matter if we take the sign or not, because in this process of completing the square, we're going to square that number every time. So negative squared turns out to be positive, positive squared turns out to be positive. So as a habit, I just don't even bother taking the sign. This really is negative 11, but when we square it, it's always positive, so I just take the number without the sign. But it's 11 over 2. And that squared, 11 squared is 121, 2 squared is 4. The constant would have to be 121 over 4 for this to be a perfect square trinomial. If this is a perfect square trinomial, then there is a binomial that you can square to get it, and it was going to be x and then minus and then half of this, x minus 11 halves squared. These are equal. Okay, solving equations by completing the square. Okay, so here's how we solve, let's go back. Here's how we solve equations by completing the square. First off, this number has to be a 1 in order for you to complete the square, and of course it is a 1. And if it's not, we've got to fix for that later, but we're going to be dealing with ones that just have 1 for right now. Okay, so here's what you got to do. You got to ask yourself, is this the constant that we need if the first two terms are x squared plus 10x? Of course, we know that the constant we need is half of it, which would be 5, and then squared, which would be 25. So I look up here and I don't see 25. So what I do here is this. If that's not the constant that we want, we just get rid of it. Okay, so we'll go ahead and add that to both sides. Don't forget we want 25 to be there. And so for starters, I move that constant out of the way. Equals 3, and I'm going to leave a space there, and then I add the constant that I want. Well, this would have to be 25. Well, if I add it to this side of the equation, I have to add it to this side as well. So we're going to add 25 to both sides of the equation. Now what I just did was I created a perfect square trinomial here. I completed the square. By picking the correct constant, we complete the perfect square trinomial. We know that every perfect square trinomial is the square of some binomial, so on the next step we take this and write it as its binomial squared. Now what's the binomial squared? The x without the squared, whatever this sign is, half of this. This is x plus 5 squared. Now over here when we add these numbers we get 28. So we have the equation x plus 5 squared equals 28. Okay, now, if we want to get rid of that square, think back to the last section. What do we have to do? Take the square root of both sides. So square root and square cancel on this side, and we get x plus 5. Now, as you remember from the last section, when you take the square root or use it as an operation in solving equations, you got to preface it with plus or minus. And we're going to have a step where we're going to have to simplify the square root of 28. So largest perfect square factor in 28 is 4. We have the square root of 4 times the square root of 7, which will be 2 square root of 7. And then finally getting x by itself by subtracting 5 from both sides. My class knows to put that minus 5 in front of the plus minus. So we have x is equal to negative 5 plus or minus 2 square roots of 7. Let's all realize that this isn't a satisfactory answer for my class, but this is equal to two different answers. It's equal to negative 5 plus 2 square root of 7. It's also equal to negative 5 minus 2 square root of 7. So those are two different answers. This is a kind of a compact way of writing both of them. Okay? You try this one. Okay, we should have gotten 4 plus or minus the square root of 15. Working through this really quick, let's look at this. We want to see if this is the right constant for this to be a perfect square trinomial, and in our minds we would say 8 divided by 2 equals 4 squared equals 16. We need to see 16 here. It's not 16, so we get the 1 out of the way by subtracting it from both sides. And then we do this work. I obviously did it twice here. And so now we add that 16 to both sides, and this is what we get. Of course, x squared minus 8x plus 16 is the same as x minus 4 raised to the second power. It's going to be this sign, and half of this, so x minus 4 squared. Negative 1 and 16 is 15. Take the square root of both sides to get rid of the square. Don't forget to put plus or minus on the number side. And the square and the square root cancel. We get x minus 4 equals plus or minus the square root of 15. Get x by itself by adding 4 to both sides. Put it in front of the plus minus. There's our answer. Okay. All right, you try this one. Okay, this one was a little bit harder because this number is not an even number, so we're going to run into fractions. But the first thing we want to do if we're asked to solve this by completing the square is to check to see if this is the correct constant for this middle term. And what should this middle term be? Well, half of 7 doesn't reduce, squared is 49 over 4. Is this 49 over 4? No, it's not. We're going to get rid of it. We add 2 to both sides. We've gotten rid of it. Now we want to add in what would make this a perfect square, or we complete the square by adding 49 fourths to both sides. Okay, so when we add 49 fourths to this side, we just get that trinomial. Over here, though, I've taken a few steps over here to change 2 into fourths, and of course 2 is going to be 8 fourths. 4 times 2 is 8 fourths. Okay, so 8 fourths and 49 fourths give me, I don't know where I got 53 from, but that's certainly wrong. So let's change that. We can change this as we go here, and that's going to be 57 fourths. Okay, so gonna have to change that as well throughout the whole thing. That should be 57, that should be 57, that should be 57, that should be 57, and 57. Okay, we'll go back and change that real quick. Okay, all right, so that's going to be, and this should be 57. Okay, all right, so 57 fourths. Okay, so and then this, what binomial do you square to get this? X plus half of this. X plus 7/2 squared is equal to 57 fourths. Okay, we then take the square root of both sides to get rid of the square. We get just x plus 7/2, and of course we do the plus minus, and we're going to put square root of 57 over the square root of 4, which is going to be 2. Okay, so that's where this 2 came from. And then get x by itself by subtracting 7/2 from both sides, and it goes in front of the plus minus, so we have negative 7/2 plus or minus square root of 57 over 2. And since these are the same denominator, if we wanted to, we could put all of that over the same denominator too. You might see the answer like this in the back of the book. I wouldn't have any problem with you stopping with this answer though. Okay, another one to try. Okay, well, another odd number right here, so we're going to end up with fractions, but the number we would be looking for would be half of that number squared, or 3/2 squared is going to be 9 fourths. Clearly this is not 9 fourths, so we get rid of that plus 5 by subtracting 5 from both sides. Okay, then we add in the 9 fourths that would complete the square, or would make this into a perfect square trinomial, so we add 9 fourths to both sides. Okay, and then poof, a bunch of numbers changed. I saw a mistake and went back and corrected it. So we have negative 5 is equal to negative 20 fourths, left off the negative, and negative 20 fourths plus 9 fourths will be negative 11 fourths. So when we add over here, we get negative 11 fourths. Okay, what binomial squared is equal to this perfect square trinomial? X plus half of this squared, so x plus 3/2 squared is equal to negative 11 fourths. We take the square root of both sides. Over here we'll take the square root of the numerator and square root of the denominator, and the square root of 4 is going to be 2. The only thing we can do with the square root of negative 11 is take the negative out as I, and then of course it goes away on this side, the cancel, and we get x plus 3/2. We subtract 3 halves from both sides to get x by itself. We put that negative 3 halves in front. Okay, and I still have another mistake here. We've already gotten rid of this, hadn't we? So that should be x equals. Okay, we'll correct that. And then x equals negative 3 plus or minus I squared 11 over 2. Solving by completing the square when the leading coefficient is not 1. Now, if you remembered a little earlier, I said we always have to have a 1 there, and if we don't have a 1, well then it's a problem. So to solve by completing the square with the leading coefficient must be 1. So if there's something else, then the entire equation must be divided by that number. So in example number 1 here, with coefficients on the squared term being other than 1, something else, then we're going to have to divide by that. Okay, so what I'm going to do is I'm going to divide everything in this equation by 2. Everything. Every term. Okay, the 2's cancel. That gives me x squared. That was the desired results I needed. I had to have a leading coefficient of 1 in order to complete the square. And that's going to be minus 2x, and that's minus 7, and it's still equal to 0. Okay, so these are equivalent equations, and of course then is this what I'm looking for here? To complete the square, it's probably not, but every now and then it is a perfect square trinomial, but we'll get that 7 out of the way. So we have x squared minus 2x plus whatever is equal to 7. Half of 2 is 1. 1 squared is equal to 1. I want there to be a 1, so I add 1 to both sides. Let's just stick it in like that. Okay, this is a perfect square trinomial now, and it is the square of x minus half of this, or x minus 1 squared, is equal to 8. We take the square root of both sides, and we have x minus 1 equals plus or minus, and we'll look at the square root of 8 as the square root of 4 times the square root of 2, or 2 square root of 2. And then we add 1 to both sides, and we get x is equal to 1 plus or minus 2 square root of 2. All right, let's get you to try one of these. All right, pause. All right, again, the directions are to solve by completing the square, and we notice that we don't have a leading coefficient of 1, so whatever this number is, we're dividing every term in this equation by that number, or divide everything by 2. We get x squared minus 6x plus 7 equals 0. Is this what we want to see right here? And of course what we're looking for is half of 6, or 3 squared, 9. This is not 9, so I'll just simply subtract it from both sides. Now I could have just added 2 to both sides to create a 9, but we're just going to go with the same set of rules for all problems, and that is if it's not right, get rid of it and then put in what you do want. Okay, we get rid of it, we add the 9 to both sides, and of course we get x squared minus 6x plus 9 equals 2. This is a perfect square trinomial, and it is the square of x minus 3, or this, without the squared, this sign and half of this. X minus 3 squared equals 2. Take the square root of both sides, put plus or minus on the side that's just the number, and you get x minus 3 equals plus or minus the square root of 2. That doesn't simplify. Get rid of the negative 3 by adding 3 to both sides. It goes in front. X equals 3 plus or minus the square root of 2. All right, let's try one more. All right, so we notice that it doesn't start with a 1, so we divide everything by whatever this number is, and we divide everything by 5. We get x squared. 10 divided by 5 is minus 2. 30 divided by 5 is plus 6 equals 0. Okay, we want to complete the square. Is this the constant that we want to see here? Well, it would have to be half of 2 is 1, 1 squared. This would have to be a 1, so I'm just going to get rid of the 6 by subtracting it. And of course I could just get this to be 1 by subtracting 5 from both sides, and I realize you can take that shortcut, but I'm just going to always get rid of it and then add in what I want. So I'm going to subtract 6 from both sides, then I'm going to add in the 1 that would make this a perfect square trinomial, and we have x squared minus 2x plus 1 equals negative 5. This perfect square trinomial is the square of this binomial, x minus half of it. And so that's x minus 1 squared equals negative 5. Taking the square root of both sides, the square and the square root cancel. We get x minus 1 equals plus or minus. The negative comes out as I. That's the only thing I can do in simplifying this radical, is I can take the negative out as I. and then I get x by itself by adding 1 to both sides. The 1 goes in front of the plus or minus, so we get x equals 1 plus or minus I squared root of 5. Okay, you try this. Alright, well this one got a little more sticky because 16 is not divisible by this number that we're going to divide everything by, but we have to first make this a 1, so we divide everything by 3. So 3 over 3, 12 over 3, 16 over 3, 0 over 3. We get x squared minus 4x plus 16 thirds. We'll just leave it just like that, equals 0. Of course, it's not the number that we want to see here, so we subtract 16 thirds from both sides, and then we come over here to find out what we do want. So we're going to complete the square by taking half of 4, or 2, and squaring that 4. We're going to add 4 to both sides. Now to add 4 to negative 16 thirds, I've come over here and I said 4 equals what number over 3? 3 times 4 is 12 over 3 is the same as 4. So 12 over 3 plus negative 16 over 3, and that's going to give me negative 4 thirds. So all this is going to add up to negative 4 thirds. Factoring the perfect square trinomial into the square of the binomial, it's going to be x minus half of this squared, or x minus 2 squared. We then take the square root of both sides, and I've done this square root of negative 4 over square root of 3, and put the plus minus in. In the numerator, the negative comes out as I, the 4 comes out as 2. We have 2I over the square root of 3. We can't leave a radical in the denominator. We have to rationalize it by multiplying numerator and denominator by the square root of 3. And so we get x minus 2 is equal to plus or minus 2I square root of 3, and in the denominator the square root of 3 times the square root of 3 is 3. Get x by itself by adding 2 to both sides, put it up front. X equals 2 plus or minus 2I squared root of 3 over 3. This answer is okay, but just in case the author writes it as one fraction, then you'd have to write 2 as thirds. 2 is equal to 6 thirds, so I replace the 6 with 2 with a 6 and put everything over 3, and this is also an acceptable answer. Okay, now we're going to talk about changing from standard form to vertex form. You'll remember in earlier lessons we changed from vertex to standard, and we changed from intercept to standard. Well, the reason we didn't go standard from standard to vertex is because we have to know how to complete the square to do that. Okay, so if you're given, just a kind of reminder here, that standard form is y equals ax squared plus bx plus c, and vertex form is y equals a parentheses x minus h squared plus k. Alright, so here we're going to change something that's in standard form to vertex form, and we've got a y here instead of a 0. So here's how we do this. Okay, when we get through, we want this answer to be y equals, right? We're going to go from standard to vertex. Okay, so since the left-hand side is exactly like we wanted in the answer, then we take a slightly different approach to completing the square. Okay, first thing we notice that there is a 1 here. Well, that's good. So here's what we do in this case. Since we don't want to mess up this this y, it's already exactly like we want it. So what we do is we just take this constant if it's not the one that we want, and the one that we want is going to be 3 squared or 9, right? We want to see 9 here. It's not 9. So what I do is I just kind of push it out of the way and just pretend it's not there. Then I come back to these two terms and say, okay, I want to complete the square. And again, I need half of 6 squared, or I want 9. So I put plus 9 in this side. Now, normally when we add something to one side of an equation, we add it to the other. But again, it's already just like we want the answer to be. So on this one, we don't add it to both sides, but we add it and subtract it from the same side. Okay? So that really, the net effect of plus 9 minus 9 is adding 0 to the side, and it doesn't change the value, but it does change the way it looks. Then what we do is we put parentheses around those first 3 terms. That's a perfect square trinomial, so we have y is equal to, now what binomial squared is equal to this sign, and half of this? It's x plus 3 squared, and then all we have to do is take these two terms out here, negative 9 and positive 16, and we get plus 7. Now, when I ask you to do this, I'm probably going to ask you to tell me what the vertex is. Pretty easy test question. And the vertex is the opposite of this for the x, and whatever this is for the y. It has a vertex at negative 3, 7. Okay? All right, you try this one. All right, again, we're first going to look here and make sure it has a 1 here, and it does, so there's not an extra step on this problem. And of course, the perfect square trinomial for 8 as the middle term would be 8 over 2 is equal to 4. 4 squared is 16. It would have to be 16. It's not. So we take the positive 11, just kind of push it out of the way and pretend it's not there for a moment. And we look at the first two terms and we complete the square. Now we just said it was 16 that we wanted there, so what we do is we add 16 but come right behind and subtract 16. So the net effect to this side is 0. That's opposed to adding 16 to both sides. And again, we want to leave that y like it is because it's going to have to be y by itself at the end. So we've sort of invented a little way to not disturb the left-hand side of this equation. All right, so we put parentheses around the first 3. We know that's a perfect square trinomial. Every perfect square trinomial is the square of some binomial. This one's the square of x minus half of it, 4, x minus 4 squared. And the negative 16 and the positive 11 add up to be negative 5. Okay, so now we've got it in vertex form, and we'll probably be asked to tell what the vertex is. It's x is opposite of this, and y is whatever this is, has a vertex at 4, negative 5. Okay, one more, except this time we don't have a 1 in front of here. It's not a 1, so here's what we got to do. We have to divide everything by 3. And we get y is equal to, and y has to be divided by 3 as well. Now we have to mess with that side. I don't necessarily want to, but we have to. So we have x squared plus 2x, and then plus 16 thirds. We move the part that we don't want out of the way. Okay, we come in here and complete the square. So our middle term is 2. We want half of that, and then we want to square it. So we add 1 and subtract 1. Okay, and then that's going to equal, we'll put parentheses around these 3. We can write that as the square of a binomial. It's x plus 1 squared. Now over here, negative 1 is equal to how many thirds? Negative 3 thirds. So I have negative 3 thirds and a positive 16 thirds. So what I have is plus 13 thirds. Okay, it's equal to y over 3. All right, now almost done, except I don't have it y equals, so I have to take everything and times it by 3 now. Okay, so that'll cancel those 3's out. 3 times this will be, so I have y equals, I'll just put a 3 in front of it, and x plus 1 squared. And I have to multiply this by 3, so it's 3 times here, 3 times here, and 3 times here. And then, of course, the 3's cancel, and I get plus 13. So y equals 3, x plus 1 squared plus 13. Vertex at negative 1, 13. All right, you try one. Okay, this last problem here, everything's got to be divided by this number if it's not 1. So everything, this y divided by 3, 3 divided by 3, 12 divided by 3, 1 divided by 3. The 3's cancel here. This stays y over 3. We get x squared minus 4x, and the 1/3 is not the number that we want because the number we want is 4 divided by 2, or 2. 2 squared is 4. We want to see 4 here. So we add and subtract 4 to both sides. Okay, we put parentheses around this. That perfect square trinomial is the square of this binomial, x minus half of it squared. And then negative 4, well, negative 4 is equal to how many thirds? Negative 4 is equal to negative 12 thirds. Negative 12 thirds plus 1/3 is negative 11 thirds. So all of this becomes negative 11 thirds. All right, now we put the whole thing in brackets. So I copied it down again, and we times everything by 3. 3 times this one, 3 times the parentheses, 3 times the negative 11 thirds. Okay, the 3's cancel, we get y. That 3 just stays there. We don't do anything with it. These cancel, and I get negative 11. I now have it in vertex form, and the vertex is at the opposite of this 2 and negative 11. And it looks like that's the end of the video. Thank you for watching.